Okay, once again, welcome back to our channel and good day everyone. Again, we have a new topic, a topic in trigonometry where we will be introducing on how to arrive with arc length and the area of the sector of the circle. Now here is a figure showing a sector of a circle which is the shaded part. Actually, there are two sector of a circle. So we have the smaller sector and a bigger sector. And the central angle here is 360 minus the central angle theta. Now, I'm interested or we are interested to solve for the sector which is the smaller one. Okay? Now, this is the arc length is this one. And then we also need to determine the area of the sector which is denoted by A. Okay, now let us show how the formula for A's and area will be derived. For the arc length is, so I have to form a ratio between A's and the entire circumference, this one. Wherein the entire circumference is 2 pi r. Okay, and that's equal to the central angle in ratio also with the complete rotation of 2 pi. So our theta here will be expressed also in terms of region. Now when this is simplified, the 2 pi expression will be removed and we have a product of r and theta. So theta is in region, so this is a formula for the arc length, and this is our is, which is a product of r and theta. So if the region is in region, so if the angle is in region, I mean the angle theta, then our r. So the unit of our r will also be the unit for our is here. Okay? So considering the area of the sector of a circle A, so I can also take a ratio between A or the area of the sector with the entire area of the circle. So the area of the circle is pi r squared. And I can also consider a ratio between the angle and the entire rotation, which is 2 pi. So simplifying, removing pi, so I arrive with an area formula which is 1 half of r squared times the theta, which is the area of the sector of the circle. Again, our is the arc length. Our A is the area of the sector of the circle. Our R is the radius of the circle, and theta is the central angle. And in order to use this formula, so our theta here will be expressed in terms of region. So our conversion of units will be needed if our angle is not expressed in terms of region. Now here is an example. Circle having a radius of 8 inches. So the sector of a circle has a central angle of 135 degrees, and we are asked to determine the arc length or the intercepted arc, so and the area of the sector of the circle. Now from the given, we have a radius of 8 inches, a central angle of 135 degrees. So in letter A, we are asked to find S. But there's a little problem here because our angle here is not expressed in terms of region. But we can always convert using our conversion or knowledge and conversion in the previous discussion. Okay, so our is a product of r and theta, and our r is 8 inches. So the angle is 135 degrees converted to in region using this conversion factor. Pi is to 180 degrees. So we have a product between them, and that is 6 pi in a unit of inches, or that is in decimal 18.850 inches. In letter B, so just use the formula that A is equal to 1 half of r squared times theta. So we have 1 half of 8 inches, this is in square, multiplied with the angle which is 135, which is to be converted on the same process as this. So our conversion factor is pi is to 180 degrees. So we obtain a value of 24 pi square inches, and approximately that is 75.398 square inches. Now, in the next example, so there is a minute hand of a clock which is 15 centimeters long, and you are asked how far does its tip travel in 42 minutes. So I need a figure to visualize this. So if this is my minute hand, and the minute hand will be moving in 42 minutes, so Each division here, this is 5 minutes. Another 5 minutes, correct? This is 15 all in all. This is 30 minutes. That's 40 minutes. So if I have 42 minutes, so approximately, this is the final position of my minute hand. And this is the angle that is formed as the minute hand will be rotated. Okay? So, the length here is the radius, which is 15 centimeters. And the formula for our S is a product of R and theta. So, knowing our R as 15 centimeters and the angle is expressed in minutes, which will be converted in terms of radian. So, we have 42 divisions in minutes. And then, the conversion factor is, so we have a complete rotation wherein we have to take how many divisions? 60 division for a minute division. So, 2 pi radian is to 60 minutes. So, we can now multiply and come up with a result which is 21 pi centimeters. Or that is 65.973 centimeters. Number 3 is an hour hand that is having a length of 6 inches. What is the area covered as the hour hand moves in 3 hours and 25 minutes? Again, to visualize what is given, this is my figure. I have the hour hand pointing on 12 o'clock direction, and then it will be moving in 3 hours. This is 3 hours and 25 minutes. So, under a minute division, so if this is 25 minutes, so it means every interval here will take a 60 minutes division when the hour hand is moving. So, this is 60 minutes when that is 1 hour as it moves. No? So, that is another 60, that's another 60, and this is approximately your 25 minutes. Okay? Now, the formula for finding the area of the sector of a circle which is required in this problem is equal to 1/2 r squared theta, and our theta must be expressed in a radian unit. Okay, now, solving for theta using the hour division. So, if we have to base it in an hour division, our angle here is expressed in hour and minute. So, the minute part will be converted in terms of hour to combine them. So, we have 3 hours plus 25 minutes, and 1 hour is 60 minutes. Okay? So, that is why we obtain 41 over 12 hour. 41 over 12 hour will be further converted in terms of radian. There are 12-hour division in one complete rotation, correct? Because this is in hour. And my conversion factor is 2 pi radian. And that is 12 hours. So, we come up with a value of 41 over 72 pi radians. So, since there is already an angle which is expressed in radian, so I can use the formula for our area. Because your area, or the area of the sector, is the area covered by the hour hand, which is 1/2. Our R is 6 inches. Then this is in square. So, we can have the angle which is 41 over 72 pi. So, we arrive at the result which is 41 over 4 pi square inch, or approximately that is 32.201 square inch. Now, if you choose to consider the minute division, okay, that's also possible by writing your angle in terms of minutes. So, 3 hours converted to minutes, we know that in every hour, in a minute division, so every division, that is 60 minutes. So, 1 hour is 60 minutes, and we can add the 25 minutes part of an hour. So, all in all, this hour hand will be moving in 205 minute division up to this extent. So, if every division ay 60 minutes, another 60 minutes are 60 minutes and 25. That is why we have 205. So, if we have 12 division as we take a complete rotation, so every interval has 60 minutes. So, 12 times 60 is the total number of minutes in one complete rotation converted to in terms of radian. As our conversion factor, so 2 pi radian is to 720 minutes when one complete rotation of the hour hand is considered. So, the 205 minutes will be multiplied with this conversion factor, and then we come up with 41 over 72 pi, which is also the same as this. Okay, so whether kini mong gamiton or that one, you will arrive with the same result. Now, the last is a different problem. So, we have a point on the surface of the Earth, which is described as 1,500 miles north from a point on the equator closest to P. Find the latitude of the point in degree. Assume that the radius of the Earth is 3,960 miles. This problem is taken from College Algebra and Trigonometry by Latitude. So here is a figure which can be part of your solution. Okay, so if this is the Earth which is in a form of a sphere, so there are imaginary lines. So there is a line that separates the northern hemisphere and the southern hemisphere. Now a point P is located from the equator going north. So a point P having a distance or an arc length of 1,500 miles. Now it is assumed that the radius of the Earth is 3,960 as the radius. So this is a sector of a circle where we have an arc length given. Okay? Now, the angle here, theta, is the latitude of the point P. So, if we can solve for this angle, the value of the angle towards north is your latitude expressed in terms of a degree. So, we have imaginary lines. So, this is actually a meridian. Okay? Now, solving for the angle theta, which is the latitude of P, knowing our R and our S, so we can use the formula is equal to R theta. S is 1,500 miles. The angle is 3,000. The value of R is 3,960 miles. So, miles will be out because theta here will be unitless being expressed in a unit of radian. So, 1,5 over 3,960 radian. So, this will be converted in terms of, in a unit of degree. And this is my conversion factor. Pi radian. So, radian will be out. And we have a unit which is in degree out from 180 degrees. Multiplying them, we arrive with 27.703 degrees north. And this is the latitude of point P. Okay, so thank you for being around. And don't forget to subscribe, especially when you are new to our channel. And try to share this to others para daghang makasunod sa atong mga discussion dire, and this can be helpful to them, no, hopefully. Okay, so until the next video, see you and bye-bye.